All right, so I've run into a bit of an issue and I want to maybe challenge Gomes to do some experimentation, maybe MTech as well, but yeah, we'll see. Uh, I found that the meters are conflicting with the experiments quite heavily. Um, and I guess the easiest way is just to show what happens. So here, what I've got here is one of these jute thief type oscillators that I've hand wound onto this bobbin. There's no core, it's just an air core, and it's basically designed this way, where the coil that connects to the base is connected to the negative, and the one that's connected to the collector is connected to the positive. There is no direct coupling. It will just be an inductive coupling, which also means that when you turn the power on, the unit does not power on itself. It has to be jolted into life, I guess you could say. So basically that's what I've got. This is just a sense coil. It's basically just going to tell me if the system is on. If I don't have a load connected. In this case, I do have a load connected, exactly the same as before, that I had set up for this. Everything's the same. It's just not all connected at this, right now. And the problem comes on this side when you're measuring this positive and negative on this capacitor here. The meter picks up or feeds into this capacitor somehow. Maybe it's through that negative resistance. I'm not sure, but it is affecting the whole results, which means, yeah, you need to disconnect the meter to be able to see if this is working properly. And grounding it, yep, that's fine, you're grounding it, but if you wanted to do a float, the meter then looks like it's still charging the capacitor even without ground. But yeah, it's the meter charging it, nothing else. Or at least that's what it looks like. So I'll show quickly what I mean. This is the meter that I'm going to connect to this capacitor here. That's out of the shot. Positive and negative. I'm trying to get it into shot. Yes, I know, I'm very shonky when it comes to my connections. But anyways, so we'll turn the system on. It's not turning on. The way I turn on my this one here is I have a little lead here with a lamp, and I just short the resistor, and it usually comes online. There you go. I've shorted it. Now it's unshorted. So it just needed that little jolt. Now it's oscillating. My sense coil is telling me that it's oscillating back and forth because both LEDs, which are reversed, are showing me an AC signal, although one of the sides is slightly less than the other. Our normal string is on. It's not as bright because this arrangement does not chew as much power as like this one did. We're running on, 12 milliamps, though this one's wrong, so probably about 20 milliamps, maybe 30 milliamps. Still about 1/3 of the power being used by this thing before. Though granted, that thing had a very, just quick and connection on it. Anyways, so as you can see, this LED is lit, and it doesn't have a ground connection. Touching it in all sorts of places, just like the AV plug will light the LED, but this is because of the connections of the multimeter. As you can see, it's reading 12.2 and it's climbing. If I were to connect the ground, which I have down here, I take the ground and I connect it to the AC side. It goes very bright. This goes down because our signal range is different. You can adjust that. Not in this case. I'm as low as I can go. But our input is still about the same. So yep, okay, that's all hunky-dory, that's all thing. It goes down when you disconnect it, and you get a different equilibrium that you reach from the capacitor, but that's also because of the meter. If I were to disconnect the meter, it's disconnected now, and if I were to short out this with, I don't know, let's see, this should be able to do it. Just short that out to get rid of the charge. Okay, there's no charge coming back onto that. And if I hold it wherever, there's no charge that comes back to it. If I grab it by the AC side, it's coupled to me now. That should slowly start charging, and the LED will come on soon. Oops, let's not disconnect it. Okay, why is it not? Oh, there it is. Just took it a while. So now it's going up. We don't have a voltage reading because we're not reading a voltage. As soon as I let go, not grounded. Okay, so we all see this. I wonder if this will work. But if I were to short this out, never a component around when you need it. Yeah, let's just short it with this again. Okay, so we'll short it out, and now we'll connect the meter back up. And positive, and now you can watch the meter and see how it's climbing very rapidly. So that meter, without it being connected to ground, without me touching it or anything like that, that meter alone will start charging the capacitor. Let's put this in shot again. So that meter now is charging up that capacitor. Now at first I thought maybe it's self-charge or anything like that, something like that, then yeah, but it's not. It's the meter. We can help it along for a bit. At 5 volts it's still charging. Let's go to about 8 volts. And now you see it still charges. But if you disconnect the meter, it will stop charging. So somehow the meter is translating charge into the capacitor without the earth on this side giving it that AC. Now I don't know why, because even if you just do one lead, now we can't see the meter, but even with one lead, I've done a time test, it will still charge the capacitor. So if you could, Gomes, maybe disconnect your meters from everything, give it a known load, and do some experiments to see if it's charging, if it's not charging, just to rule out the meters. Because as you can see on the ground side and things, and this does relate to what you're doing, your meters could actually be giving you, feeding your capacitors. Now I could be completely wrong. This could have nothing to do with what Gomes and MTech did, but it's just interesting to me that this is what happens. As you can see, it will reach the 12 volts, and this LED will slowly start lighting. Now, not by much, but just the meter being hooked up actually does, for some reason, somehow transfer charge to this cap. Now I can't explain why, because like it can't be the battery of the meter. The meter is specifically designed to have a diode that prevents it from being fed. I don't know. I don't design meters, and all of them seem to do that. My old one, this new one, they all seem to have this for some reason this sort of effect on this side, at least, you know, this side where it's connected to of the whole system, which would mean that anything connected to here, metering or whatnot on this side where the earth is, could have the exact same problem, where your meters are going up or doing funky things. Your capacitors are going up, your batteries are going up because of this sort of effect. Now that is still an interesting effect, because is it the battery? I mean, this one only holds 2 AAA's, giving it 3 volts, so it only runs on 3 volts. There's no way you can feed a 12-volt battery. So some of it must still be coming from the collector, but the positive and negative are acting like a ground, or some sort of resonant harmonic, I don't know. But yeah, I just thought that was interesting, and it's something that even I now need to watch out for, which is why I always use LEDs and things like that as well as indicators, because yeah, we all know how funky our meters and our measurements tools can be sometimes, including scopes. So yeah, anyways, just thought I'd throw that out there, and yeah, let me know. That would be interesting to see. Thanks.